graph of an equation is shown in the figure, write the equation in the form y equals a sine of bx plus c for a greater than 0, b greater than 0, and the least positive real number c. Well, we'll look at the graph. We see its amplitude is going to be 2 because it fluctuates between plus and minus 2. So a will equal 2. Actually, technically, the amplitude is the absolute value of the coefficient a. So plus or minus 2 are possibilities here. So we have to note that a was requested to be a positive number to know that the positive 2 is the amplitude that we're looking for. To find b, we can use the fact that the period is equal to, or is found by doing 2 pi divided by the absolute value of b. And now, since b is to be positive, we can note that this will equal just 2 pi over b for our problem. And we need to have an answer for what the period is so that we can solve for the unknown b. We can find that by transforming, or by looking at the curve and searching out a basic sine cycle. Here's one such cycle. It starts at -1 and ends at +3. That spans 4 units, so the period will be 4. So 4 is equal to 2 pi over b, and if I multiply both sides by b and divide both sides by 4, I obtain b equals 2 pi over 4, or just pi over 2. So we found the value of b that will work for this problem. We found a earlier. To find the value of c, that comes from, we can find that, I should say, by using the phase shift. The phase shift in this problem can be viewed as a phase shift of -1, where the sine curve that generally starts, be careful there, that's not going to be right. The normal sine curve starts at 0 and comes up, goes down, comes back up again. And we can see that this has been shifted from that standard sine curve either 1 unit to the right, which would give us this portion of the curve. So that could be known or seen as a phase shift of +1. But there are also lots of other possibilities. It could be that we started and shifted this curve 3 units, 1, 2, 3 to the left, and produced this segment of the sine curve. So the question is, where is the starting point? If we're starting here in a normal sine curve, has the new starting point been moved over here 4 units or 3 units to the left, or has it been moved over to here 1 unit to the right? The only way we can answer that question concretely is by using some of the requested information in the problem. Without something clarifying which value of c to use, there are an infinite number of possibilities depending on how you want to shift this curve. So the phase shift in this case, and in all cases, can be found by doing -c over b, and c is to be a positive number. Now let's take a stab and try the phase shift of +1 that we found before. We know that if that's equal to +1 and we know the value of b, then we're going to have c over b, which was pi over 2, equal +1. And if I multiply both sides by pi over 2, I see that the opposite of c is equal to pi over 2, so c is going to be negative pi over 2, and that doesn't satisfy the conditions. So +1 isn't going to be the correct phase shift to use to satisfy the requirements in the problem. So that was a bad choice. Let's try -c over b equal -3. That corresponds to the shift to the left 3 units that I noted here. If I solve that using the known value of b, I find that the opposite of c is equal to the -3 that we had times b, which is pi over 2, and that, when I solve by multiplying both sides by -1, gives me c equals 3 pi over 2. And that value of c is positive, and it will be the least positive value for c. I could, on the other hand, to get a larger positive value for c, I could have shifted this actually not just 3 units, but another, let's see, another 3. Where's our period? Period was 4 units, so another 4 units beyond that to get us to -7. That would have produced another positive number c, but it would have been not the least positive. So there's the value of a, b, and c that we need. To finish this, we can just write it out by inserting those values, which gives us this equation by inserting the a, b, and c that we found.